Okay, I think I got this IO link index and sub index worked out, and yeah, I know I need to make a video on it. Our power supply is good, and while you can't see it, I have an ignition app on my phone that I can switch this brake, and boom, our power supply is dead, or appears to be dead, and I think it looks good and dead, or looks good and emulated dead, but there is 120 volt here, and you're getting nothing out there. You'll have no idea how much work that took. But then we drop that out. We actually had to get the IO link powered up on this. And then once we have that powered up, we can turn our remote switch back on. So there you go. Like 6 hours to develop one brake that takes, I don't know, maybe 4 or 5 minutes to do in a class week, but might save somebody's life too. Probably this young and inexperienced guy right here. While I'm hot battling IO link indexes and sub indexes, I want to try to inventory a little bit of what you can do with them, because I don't see us using it really well, at least in the programs that I'm seeing. I mean, we're doing about what I'm doing on this. I got an encoder. We're grabbing an encoder value. I got a vibration monitor. I'm grabbing a vibration value. I got a pressure sensor. I'm controlling the pressure. There's a lot more you can do with these. So I want to just kind of sink into my head what all we should do or could do. I'm not sure. Right now I'm just trying to inventory, I guess, what we could do. So I just want to take these one port at a time. And I'm going to start on port one. Port one, I got an SMC pressure regulator. And I know that if you kill this pressure, if you hit the dump valve and you try to run this, then when you do, it makes a very angry noise. Now, if it's making an angry noise there, gosh, I gotta get that noise to stop. If it's making an angry noise there, then we probably should have some type of IO link diagnostics telling us that. So here it is in Studio 5000. You can even see it bouncing a little bit there. There is, I guess, well, that has to be our output pressure. It can't be our inlet pressure because it's has a steady value in it. But if we go over to our IO link and I go to process data, oops, not process data structure, it's going to tell me exactly what everything is. And so my operating pressure, well, it says our operating pressure is bit offset 16. That seems a little bit off because, well, maybe I have a lot of bits on. I definitely have, well, okay. Now the next question here, and it's a good exercise kind of building, hopefully not as bad as the last 2 days of the index and sub indexes. I'm seeing our operating pressure at 16, and I got some other thingies. Are those above or below our bouncing value? So either number 2 or number 4 are all those little bits. And okay, I have a 1 here right now, so I should be able to go to my process data. Well, so a 1 right here, that's going to be bit 0. Let me just open that up so you can see it. That's bit 0. I believe it's the one below it. I believe we have a little bit of a reverse situation going on here, and I don't know what it is exactly, but so that means bit 0 is an SSC1. What? Can we just ban acronyms? Sorry, I don't know what SSC1 means, but I should be able to go to my process data, and we should be able to find, there it is, SSC1, and it does have a 1 in it right now. That's what it's indicating right there. And if I kill my valve, and then I try to make it move. All right, so no doubt, let me turn that back on so I don't have to hear that. Oh, now the air compressor goes on. No doubt, this being a 0 would be a sad condition. I wish I knew what the world that meant. What do these question marks do? Oh, Okay, I did not realize you could do that. Turns on when the output pressure is within plus or minus 10% of the setting pressure. Oh, well that right there should 100% be an alarm. And it looks like we have some others, and arguably we should map these in on that. All right, over here I don't have a device on number 2. I do have a device on number 3. This is actually this, if I can get my camera in there, there's actually a 4 to 20 milliamp to IO-Link converter there. So we're actually picking up a 4 to 20 milliamp signal on this. And if we go look at its, actually, yeah, I wonder what Diagnostics has on it. Okay, so we have upper and lower alarms. And we have a runtime counter. I don't know how beneficial that would be, but it's neat that they put that in there. And if we go to our process data structure, oh, so you actually had 2 different configurations you could do on this one. We're just doing the basic one here and pulling the data, but also, and here's where those sub indexes and everything can come in, is we should be able to pull the rest of this out. So this one may be a neat one to play with on that. So next we have this BCM device over here, port 3, and that's actually this Balluff vibration monitoring right here. And, ooh, okay. I have a generic IODD file, another great acronym, loaded. So I've never apparently installed the IODD file for this. What I love about this Turk IO-Link is most of the time, now hopefully this isn't the reason why it wasn't there, I can just hit this web search button and that should swirl out on the internet. And that brings our IODD file in, and yeah, now we have all our info on it. And so if I go down to, let's just start at the beginning. We go down to parameter. We got some lock thingamajiggers and some maintenance thingamajiggers. And okay, we have our custom profiles. I don't know, at least I'm using custom profile 5. I don't know what that means really. Oh, and you can actually set alarms on these inside of this. Now this would be really neat to do. So, wow. I think I need to break out the user manual for this one. There's a lot in this one. But yeah, there's really cool stuff there. And yeah, then I guess if we go to the diagnostics, and yeah, not really sure on this one. This one's definitely going to take a little more time to, learn what we could do. But we should be able to get some really nice data off of this. And they have a really good AOI in this one. I don't know that there is that much I'm going to gain from it, but I should at least try. And so, yeah, here is, okay, and here's the process profiles. And you can change your profile. I think we're on profile 5 right now. And so that gives us a nice well-rounded humidity, temperature, pressure, and vibration. So a lot of cool stuff there. I need to spend I definitely need to spend some time on this one. This is the one a lot of y'all ask about, is vibration monitoring. So I should be grabbing this and sticking it up on ignition. That's what I really ought to be doing here. Might as well look at events. I don't know if it does anything. Doesn't look like it does anything. Event history, mostly reboots. Okay, that's cool. Now, might as well look at connections. Oh, well, that's kind of nice. At least they tell you what color they are. All right, I don't have anything on 5 and 6. Actually, I do, but they're not IO-Link devices. But port 7, this is a banner stack light. No, and I guess I've never loaded the IODD file in it either, so let's do a web search on that one. And it'll swirl around for a second, and voila, we have the info on it. And the main thing we'd be looking at here is the process data structure. They have a great add-on instruction that puts this right into Studio 5000. So probably not anything. Actually, we do play with the alternate colors. So I don't know, probably not on that one. And then we have an encoder here. And yep, already got an IODD file for it. And we go look at the parameters on it. Got some type of locky thing. Oh, I didn't know you could change the direction. That's funny. Actually, I still would have done the same thing. Mary Bruce doesn't watch this forever. Our trainers rotated clockwise, and when we bolted the encoders on the front of them, they were counting down instead of up. So I swapped it so the trainers now all rotate counterclockwise after they shipped from a certain point. And we probably could have swapped it there, but I do like for things to work as much as possible, right? Well, I think I might need to tighten that up, but it hadn't fallen off on the floor, at least in the few classes that ran yet. Probably got a lot of bolts that need to tighten up, but I try to make it aware as much as possible what it does out of the box works for you for most applications. Still probably was best to rotate that motor counterclockwise. And just going on down, I don't think there's anything probably stellar in here. All right. You know, actually, I don't know if we call that a multi-turn error. This is if you actually roll over. And we probably should use that to do some math to continue gathering our count. Actually, that probably is video worthy. There's our process data structure, which I'm pretty much using. Now here might be an interesting one. I don't know. Probably will have. It's been rebooted, so not now. But if we could log those rollover times, it might be something neat to do. Yeah. Well, how about that? They also gave us the connections. That gives me a little bit to work on. And then, yeah, I think I need one device. And yeah, maybe y'all can help me out. I need one device that kind of leverages some of those indexes and sub-indexes so that we can learn. Mainly, it's a great opportunity for us to learn about explicit messaging and the fact that we can get a lot more data. Like actually probably that power supply, which is unfortunately on a Micro 850 PLC. It's not the one that we actually use on this one. It probably did a really good job. It had a lot of things you could learn. But yeah. Another thing I'm working on right now is trying to work out this whole pneumatic option on the trainer. Yes, I know everything's loose on it because we're kind of just piecing together. And yes, I know I have two of these because it's supposed to be a shutoff and it is not here yet. But the goal here will be, we're going to show 3 different types of valving. We're going to talk about energy monitoring. And yeah, well, we had to mock this up. We'll break this piece off once the other cylinder gets here. I needed to adjust this cylinder, but so this is kind of the up position of the cylinder. So we could come out, and then you can use your imagination. The cylinder drops down, and you know, it grabs apart, and then it would pick up, and then run back over, and maybe come back down using your imagination, and then we'd open back up. And really our goal here would be, and we could stack some blocks. In fact, I probably will put a pressure sensor on this one. That way you can come down and it can press against something and realize that, oh, I've met the top of that. Or, you know, this may be a good place. I may put a sensor on it, an actual sensor, like a Buoy sensor. Went back to that whole thing where I said, yeah, maybe we need to do a sensor training. Yeah, that sounds really pathetic, doesn't a Buoy sensor? A sensor that can view something like, well, we have the laser sensors. Actually, that probably is it. We probably just need to rearrange. You know, this probably that laser sensor, probably shooting down, and you could say once you're to a certain height, turn that solenoid off. But so the whole point is to make a really basic pick and place. One, so you can learn about a pick and place, but also so you can learn the basics of pneumatics. That, I never forget, we added this pneumatic addition to this trainer, or its predecessor, and one of the first classes, I mean, one of the sharp guys programming, he kind of looked at it and he's like, hey, can we talk about this a second? I know that when I turn this output on, that cylinder moves, but what exactly is going through those lines to make that happen? And it's one of those things, it's like, we should have a talk about that. So we're not looking to show how to design a control system or a pneumatic system, but can we understand the components enough that we can be in the room and talk to our supplier about what we need, and be involved in that. At least have the info they need to get the right selection the first time. And and the other big piece I think to this one that is really hot in pneumatics is the energy consumption. I'm waiting on a few parts, but I've got some special pressure relief style flow controls, and we have flow monitoring coming. That's going to allow us to pick up how much flow we have. We're going to be able to identify, okay, how much energy are we consuming? We're going to do that type of calculation. And then we'll make some modifications to it. Well, one, such as an air leak to see how much that does, but also we can modify our machines to reduce their air consumption. And, air consumption is, most plants, it's one of the biggest expenses, the unaccounted for expenses, that we can save money with.